NASA has just unveiled a breathtaking new set of photos from the world's most powerful telescope, revealing never-before-seen details of Pluto. Alongside historic data from the New Horizons flyby, these images peel back the layers of mystery surrounding the icy world at the edge of our solar system. The James Webb Space Telescope has once again redefined what humanity can see. This time, it delivered the clearest, most astonishing portrait of Pluto ever captured. For decades, Pluto was little more than a blurry dot in textbooks and telescopes, distant, cold, and enigmatic. Its secrets seemed forever out of reach. But now, thanks to Webb's immense golden mirrors and finely tuned instruments, Pluto emerges in astonishing clarity. Its surface, once vague and obscure, now reveals textures, patterns, and contrasts that transform it from an icy riddle into a dynamic world full of geological drama and atmospheric complexity. Before we dive in, don't forget to hit the like button and subscribe to our channel for more updates on space discoveries. What makes this moment so special isn't just that Pluto has been imaged again, but how sharply and vividly Webb has brought it into focus. The icy plains, the rugged mountains, the shadows hinting at ancient impact craters and frozen nitrogen flows. Every feature pops with precision that feels almost three-dimensional. Where New Horizons once gave us a fleeting snapshot, Webb now provides a steady gaze, combining infrared and optical vision to reveal both surface details and subtle atmospheric processes shaping Pluto today. Webb's instruments allow scientists to study Pluto's composition in ways never possible before. Different ices reflect light in distinct patterns, methane here, nitrogen there, and faint traces of exotic compounds called tholins. These tholins, created when cosmic radiation strikes methane and nitrogen, give Pluto its reddish hue. But they're more than just stains on the ice. They represent prebiotic chemistry, the same kind of processes that may have once helped spark life on Earth. To scientists, tholins are a chemical signature of possibility, and Pluto's surface is coated with them. Pluto's story has always fascinated us. Once celebrated as the ninth planet, later, demoted to dwarf planet, it has held a near mythical status in public imagination. When New Horizons flew past in 2015, it stunned the world with the famous heart-shaped tombaugh regio and hints of geological activity. But that encounter was brief, a single flyby lasting just hours after a journey of nearly a decade. Webb now fills in the gaps, offering a long-term watch from afar, giving astronomers the chance to track seasonal changes and chemical shifts as years go by. One of the most extraordinary revelations is Pluto's atmosphere. Earlier studies suggested it was thin and unstable, mostly nitrogen and methane that sometimes freezes onto the surface before sublimating back into gas. Webb now allows scientists to track how this atmosphere shifts with the seasons, since Pluto's orbit is so eccentric that its climate swings dramatically over centuries. Imagine an entire hemisphere plunged into decades-long winter darkness, while the opposite bathes in weak but continuous sunlight. With Webb, astronomers can actually watch these cycles unfold in slow motion, revealing how gases migrate across the globe, creating hazes and faint, shifting skies. Even more exciting is what Webb may be confirming beneath the surface: evidence of a hidden ocean. Data suggests Pluto's interior may still retain enough heat to keep liquid water locked under its icy shell. If true, Pluto joins the ranks of ocean worlds like Europa, Enceladus, and Titan, places that could, in theory, harbor conditions suitable for life. This possibility transforms Pluto from a cold, forgotten outcast into a vital piece of the habitability puzzle. If liquid water exists beneath miles of ice, and if energy sources like chemical gradients are present, then Pluto may not be entirely lifeless. Webb's imagery also sharpens our view of Charon, Pluto's largest moon. Together, the pair form a unique binary system, orbiting around a shared center of gravity that lies outside of Pluto itself. Charon's scarred surface, carved with chasms deeper than the Grand Canyon, contrasts Pluto's more varied landscapes, hinting at different evolutionary paths shaped by billions of years of gravitational interplay. Smaller moons like Styx, Nix, Kerberos, and Hydra add to the complexity, wobbling in chaotic orbits that scientists are only beginning to fully understand. These moons may hold clues about Pluto's violent past, possibly born from a massive collision billions of years ago. But beyond science, there's an emotional impact to all of this. For generations, Pluto has symbolized the outer frontier of our solar system, the lonely wanderer at the edge. Seeing it now in such vivid detail reignites that sense of wonder. Categories like planet or dwarf planet fade in importance when confronted with the sheer complexity Webb has revealed. Whatever we choose to call it, Pluto has proven itself a world worth exploring, rich in stories carved into ice and stone. The cultural ripples are enormous. This image will inspire classrooms, artists, and dreamers for decades. Children today won't just imagine Pluto as a dot. They'll see its mountains, its plains, its colors. They'll ask questions we haven't thought of yet. And that curiosity is the fuel of future exploration. Technically, achieving this image was no easy feat. Pluto sits nearly 6 billion kilometers away. Its faint sunlight, reflected weakly back into space, is easily lost in cosmic noise. Webb's segmented mirror, spanning over 6 meters and cooled to cryogenic temperatures, was designed for exactly this kind of challenge. The fact that it captured Pluto with such clarity is not just a triumph of astronomy. It's a triumph of human collaboration and engineering. And this is just the beginning. With Webb's methods, astronomers can now apply similar techniques to study other Kuiper belt objects, worlds like Eris, Haumea, and Makemake. Each holds fragments of the solar system's earliest days, preserved in frozen silence. The Kuiper belt is a vast, icy graveyard of planetary leftovers, and yet within it lie answers to how our solar system formed. Pluto is no longer an isolated curiosity. It's the first in a line of distant mysteries ready to be revealed. Looking back at Pluto's history and human thought makes this all the more meaningful. Discovered in 1930 by Clyde Tombaugh, Pluto immediately captured public imagination as the ninth planet. For decades it reigned at the edge of schoolroom charts, a lonely world beyond Neptune. Then, in 2006, the International Astronomical Union controversially reclassified it as a dwarf planet, sparking debate and heartbreak around the globe. But Webb's images prove something powerful. Labels aside, Pluto is extraordinary. Whether planet or dwarf planet, it is a world with weather, geology, atmosphere, and perhaps even an ocean. So what does this mean for the future? Webb can't fly to Pluto, it can only watch from afar. But these images act like a roadmap for the next generation of missions. If a new spacecraft ever returns to Pluto, it will go with a sharper sense of where to look, guided by the secrets Webb has already uncovered. Perhaps future missions will carry orbiters, landers, or even cryobots designed to drill into its icy crust in search of liquid water below. For now, Webb has set the stage, and the next chapter of exploration is waiting. At the heart of it all, Webb's portrait of Pluto is about more than just science. It's about perspective. A century ago, Pluto was unknown. Then, it became a speck in Clyde Tombaugh's telescope. In 2015, New Horizons gave us our first close-up. And now, Webb has transformed that speck into a living, evolving world. Each step builds on the last, reminding us that discovery is not a single leap. It's a journey, a chain of revelations stretching across generations. Pluto, once the frontier, now stands as a bridge. A reminder that the solar system is not finished teaching us. And with Webb's golden eye turned toward it, We've taken one step closer to understanding not only Pluto, but our place in the cosmos itself. So, what do you think? Should Pluto remain a dwarf planet, or has Webb shown us that it deserves to reclaim its planetary crown? Share your thoughts in the comments below, and don't forget to like and subscribe for more cosmic discoveries.